billions of years passed. Many of the first stars burned out and died, turning into super-heavy white dwarfs or strange black holes. But all the time new ones were appearing, formed from vast, spinning clouds of molecules that collapsed in on themselves, pulled together by the force of gravity. Here comes the sun. About 9 billion years after the beginning of the universe, roughly halfway along one of the arms of a spiral galaxy, a new star began to form from a molecular cloud. Most of the stuff in the cloud went into the star, but not all. The rest formed a disk, billions of kilometers across, whirling around with the new star at its center. The stuff in the disk began to clump together in lumps of different sizes. Some of these lumps eventually ended up as large ball-shaped objects scattered through the disk. The ones near the new star were dense and rocky. Those farther away were much less dense and were mostly made up of gas. Those even farther away were frozen balls of ice. All of them revolved around the star in tracks shaped like ellipses, more or less squashed circles. That was just over 4.5 billion years ago. The spiral galaxy is the one humans call the Milky Way, and that new star is our sun. The big ball-shaped objects are the planets in our solar system. One of the rocky ones, the third one from the sun, is Earth, our home. How it changed from a newly formed ball of space stuff to the living planet we know today, and how we humans became a part of the life of the planet, is an extraordinary story, perhaps the greatest story ever. It's certainly been a long time unfolding. To begin with, there are some quite big questions to explore, such as, what do we mean by life? How can we reconstruct the past? And how, and when, did the Earth first become inhabitable by creatures like us? The first 2 billion years. The first period in Earth's history, from its formation to around 4 billion years ago, is called the Hadean Eon. The period from 4 to 2.5 billion years ago is called the Archean Eon. Hadean Eon, 4.57 billion years ago. Earth is believed to have formed 4.57 billion years ago. It was almost certainly molten to begin with, although a solid crust would have formed within a few million years as its outside cooled. No rocks from this first crust are known to have survived to the present day, which means it's not possible to date the planet directly. However, using a technique known as radiometric dating, it is possible to work out the age of the oldest meteorites, rocks from elsewhere in the solar system that have crash-landed on Earth. It's believed that their age, 4.57 billion years, is the same as that of the solar system's planets, including Earth. 4.5 billion years ago. Just over 4.5 billion years ago, Earth's crust probably melted again when a planet-sized object crashed into it, forming the Moon in the process. 4.4 billion years ago. By 4.4 billion years ago, Earth had a solid crust again, and a thick atmosphere consisting of a mixture of gases. There's no agreement on exactly what this mixture included, although there was certainly no oxygen. The oldest known surviving substances from Earth's crust date to this period. They're small crystals of a tough material called zircon, and their chemical composition